Hello. Sorry for cutting off the previous video. My headphones suddenly stopped working. Okay. It's okay. So let's continue. So given that the matrix D is this, calculate the value of M if matrix D does not have inverse matrix. So in this case, you need to remember that if it doesn't have an inverse matrix, well, how did they know that? Well, they knew that because the determinant was zero. Determinant was 0. So what you do, you calculate the determinant. So negative 2 multiplied with m plus with 1 with negative 6. So negative 6, it must be equal to 0. And if you do this, you will get that m is equals to um oh it must be negative, sorry. So you will find that m must be equals to 3. And now if D inverse is this, so you got D and you got the D inverse, so now you're just gonna do the multiplication, and now you'll get 1100. So you know that you will get this value. So if you just do the multiplication, actually you know what, let me do the multiplication. Okay, D is m1 negative 6 negative 2, and D negative 1 is negative 1 negative 1 over 2 3 1. Okay, let's do it. So D multiply with negative 1. Okay, M negative 6 1 negative 2, you multiply with negative 1 negative 1 over 2 3 and then 1. So honestly, right, you don't have to do any of this, you just have to do this thing. So let me just multiply and add first for x, right? So x is equals to negative 1 times with m, will get negative m, and you multiply negative 6 with negative 1 over 2, you will get positive 3. And you know here should be 1, so you replace x with 1, and then you'll know that m is equals to 2, and that's all. Okay, so they have given here this thing. Oops. Okay, it's okay. So you know that if you multiply with anything, and then you got the identity matrix, that means A is actually an inverse. So in A is the inverse of this matrix. So what do we need to do? We just find the inverse matrix of this, and that's what they did. And now you got A. And okay, so now you know what's the inverse matrix. But what's the point of finding inverse matrix? Well, that's actually uh, a big use of finding inverse matrix, right? So, and that's where when solving simultaneous linear equations. So I think we've already seen this, but in admats, or maybe it's okay if you haven't seen this. But let's say I got this, right? 2x plus y is equals to 1. Actually 0. So if I want to do this, I might use the calculator, or I might use some other ways, like maybe representing x equals to 1 minus y, and then um, replacing x with 1 minus y, and then you get 1 minus y plus y is equal to 0, and then you solve for y. So these are some methods that you can use to solve these two equations. But one of the things that you can also use is metrics. So how are you going to do that? Well, I'm going to take the coefficient of these variables. So the coefficient of this is 1. Here is 1 and here is 1, 2. So I'm going to write that in a matrix. And then I'm just going to multiply with x and y. And that must be equals to 1 and 0. And this is true because if you actually try to multiply this matrix with this matrix, you will actually get this value. So if I take 1 1 sorry 1 2 and 1 1 and you multiply with x y, I will get x plus y here and then 2x plus y here. So this thing is equals to this, so that means x plus y equals to 1. That's what I've written here, and here 2x plus y equal to 0, and that's what I've written here. So basically you're representing these two equations in matrices. In this case you're representing them in 3 matrices. So what's the point of this? Well, let me show you the formula. So let's say a times x is equals to b, right? And both 3 of them are just matrices. So what I'm going to do now, I'm going to multiply with inverse of a. So inverse of a, multiply there, and then I multiply here. So I multiply here inverse of matrix, inverse of a, and here inverse of a. So if I multiply inverse of a with a, I'll get I, which is the identity matrix. And if I multiply the identity matrix with any other matrix, well, I need to get the same matrix, so I'll get x. So this must be quite similar to this, right? So in this case, so let me remember this. So in this case, this is a and this is x and this is b. So if I need to find x, then x must be inverse a multiplied with b. So you just find the inverse of this and then you multiply here, and then you will get x y value. So just let me do one example. Okay, let's see this. Okay, so x minus 2y is equals to 1. 3x minus 4y is equals to 4. So if I try to represent this in matrices forms, then I will get 1, negative 2, 3, negative 4. How? I just took the coefficients. So 1 here, negative 2, 3, negative 4. Simple. And now I'm going to just write xy. This is equals to the value here. So 1, 4. Okay, now I'm going to find the inverse of this. So the inverse of this matrix, right? Also I also can write to represent inverse of matrix. I can write the matrix and then I just write the power -1. It's same as writing a -1. Okay, so how to find this? Well, you take 1 over 1 times -4, you get -4. Then you minus with the multiplication of this and this, so you get -6. So -6. And now the matrix is, you would swap this, you get -4, 1. Actually, let me make it bigger. Okay, and you change the sign of this and this, so -3 and 2. So now this will become -4 plus 6, so 1 over 2. And then if I just do the scalar multiplication, I'll get -2 here, then -3 over 2, and then here I'll get 1, and then here I'll get 1 over 2. And oops, so that's all. That's how you solve linear equations using the matrix method. And then I guess solve the linear equation using the matrix method. It's the same thing. And okay, so let's look. If you look at this, right? Okay, that is 3 plus p over 2 equals to q. So you need to bring both of the variable in one at one side. So q is equals to minus p over 2 equal to 3. So basically, I brought this to here. And now the coefficient of this is 1, and the coefficient of p is negative 1 over 2 p. So this is the coefficient of p. So just so you guys don't get confused in that question. And I guess that's all. So good luck. Thank you.